Welcome back. We've taken a look at case 1 and case 2 of debt funding in project finance. Right? And as I mentioned, that whenever you are building your project finance, always think about this. Just think about different things. You need to think about flexibility, such that by the time you are presenting it, they ask for this. It's easy to just change on the spot, and your model will automatically update. So we've taken a look at case 1 and case 2, and let's take a look at case 3. So I'm going to duplicate this, my case 2. Let me duplicate my case 2, and let me call this case 3. So I'll just change the number to 3, and let me update our assumptions. So let's say our loan inflow period will come in year 1, and our repayment will be over 5 years. Let's keep the interest constant. Now, the next one that we want to discuss here now is what we call this our principal. Let me put it in a border so that we kind of understand the case we are discussing here. So here, we want to discuss these repayments. As I explained in the previous video that, yes, we are trying to keep things simple, right? It's basically saying, hey, give me $500 million in cash today, and I will give you back over a period of 5 years. That's just the simple thing. But the benefit that the person that is giving us this fund is getting is the interest expense. So which means our interest is always charged on our outstanding balance. And we now have something we call more like a waterfall interception, such that your principal repayment will be increasing while your interest expense is decreasing. And it could be the other way around, right? But we are going to see that in this our model B. So here we currently have a constant $100 million repayments. But a typical debt schedule, you hardly see a constant repayment like this. So it's always that waterfall interception. So that interest, your repayment is increasing while your interest is decreasing because it's just percent of the outstanding balance, right? So let me delete this. And now for us to now use that, there's a formula we call PMT equal to PMT. Now for PMT, it calculates the payments for a loan based on constant payment and a constant interest rate. So which means PMT add both our interest and our expense. It adds it together and give us the expected actual amount that we need to be paying every period. So you also have IPMT, ISPMT, PPMT. You can always explore that, right? And a subsequent session, we're also going to be using some of this. But for today, let's make use of our PMT. So for PMT, I'll open my bracket. The first thing it's asking for is our interest rate. So I'll click this, comma, a number of period, which is 5 years, comma, and our present value is our loan amount. And I'll close my bracket and press enter. So by default, it's going to give me negative because it's a cash outflow, cash going out. But remember, based on our past standard convention, say that all the values in your model must always be in their positive value. And the best is for you to put the description that, yes, you are deducting this. So for that, I'll come here. Some people usually put negative in front of the PMT, but I don't like to add code in my formula. So I'll just use my ABS, absolute. Right, type it in front of my PMT, open the bracket and close the bracket and press enter. So that I have it in positive value. Now, this $149.2 million is what is expected to be paid over the 5 years period, both principal and the interest. So it has calculated both of them together. But if you look down here, you see that we've calculated our interest expense already. So which means for us to get our actual principal repayment, our both equal to this our constant payment that we've gotten using our PMT. I'm going to keep that constant minus my interest expense. Remember that 149.2 is inclusive of the interest expense. Because we've calculated the interest expense, we just need to net it out of it to get our principal repayment. And I'm going to drag this for the 5 years. Right? So let's come down here and let's create a debt service so that we can see that chart, the waterfall intercept that I mentioned. So our debt service, so whenever you hear anything like debt service, that will be both our principal repayment, and what? And our interest expense. So both of them make up our what? Our debt service. So principal repayments, I'll come in here, link that, and my interest expense, I'll come in here, and I will link that, and I will drag this for the period. And you can see the repayment is increasing. Why the what? Why the interest expense is decreasing. And let's now add it together. So our total debt service, let's call this our total debt service, right? So that will be equal to my principal plus my interest. Okay, let me reformat this. Excel is act formatting thing. So let me reformat. Okay, great. So you'll see that it will still give us the same what? The same value. The same value. So let me change my border color to black. So let me change it to black. Change it to black. Okay. So you can see that our debt service is what is constant. It's the same thing. So if I sum this together, right, let's take a look at this. So we got our debt of how much? A debt of, so let me put it here. So our initial debt amount was what? Was $500 million, right? And now we are using that to repay what? Then the debt service. We are now using that to pay 748. So what is more like the benefits that has been accrued here? So that's like $245.8 million. Let me always go to add your units whenever you are building your model. It's part of the best practice, right? So let me call this net benefits, right? So taking the fact that the person is taking a risk. All right. So when it comes to interest expense, they also consider the time value of money. The owner of the cash also needs to benefit. Right. So at times, well, when we are calculating our the debt capability of a project, we usually discount the cash flow to reflect the actual effect of inflation and some macroeconomic data in it, right? So because it's a typical project finance, so you kind of gain more, but the risk is also higher. Right? What if the project did not go as planned? What if there's a default? So there are really a lot of things when it comes to the debt funding, right? So that's for our case 3, where we've applied our principal repayment.